Okay, so we just dealt with a maximum, and we found that out, and that was long. It's a long video. Sorry about that, but that's math. That's optimization. That's real life. Real life is never a problem. 9 times out of 10 is not a problem. That's actually just something. Bam, 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 done. Normally, real life actually has problems that you have to endure, and actually try to get the answer by spending time with it. So that's what we did. We just spent time enduring through an answer or through a question, persevering through. All right, so example 2 says you have 50 centimeters of wire, and you have to use part of this wire to make a rectangle that's twice as long as it is wide, and the rest of the wire, if there is any left, to make a square. So with that, the question is, what should the dimensions of the square of the shapes be if you want the total area to be as small as possible? So in other words, the area of both of them together to be as small as possible. So again, with this thinking about it, we're like, okay. We know what they're asking. They want us to find the smallest dimension, the smallest possible area. So we're looking for area again here. So we need to have the area formula, but total area also. It says total area. So we have to have the area of the shapes and everything. So we need to figure that out, all the good stuff. So first off, let's go ahead and graph it out. Let's not graph it out. Sorry, draw it out. Let's draw this bad boy out. So step 1 says to draw, and make sure we can have everything. So we have a rectangle going on here. We have a square going on right here. And with it, we're assuming that the rectangle will be bigger than the square because you're using most of it into the rectangle anyways, what they want, or what they said. So with this, it says that the rectangle it's twice as long as it is wide. So if it's twice as long as it is wide, that means, okay, we're going to call this the width right here. The width. So we're going to call this x. And our length right here says it's twice as long. So can't use two different variables here because we can't say x and then 2y because there's not the same length. So we have to make sure it's the same length because it's twice as long as the width. So if the width is x, that means the length has to be twice as long as the width, which is 2 times x. Right? All right, and then when it comes to your rectangle, your square, my fault, we can't use the same variables there because we don't know if this x right here, this width, is the same width as this side, or if this length is the same length as this side. So with that, we don't know. So what was best to do is go ahead and put a different variable there. So let's call this y. So we'll say y here and y here. So we'll call them y's. All right, so with this, we have it labeled. That's step 1. Step 2 says to go ahead and write an equation. Let's change the color. It says write an equation of what you're trying to optimize. So it's asking for a total area. So here, we're going to do the area formula. And so if we look at this actual rectangle right here, the area of a rectangle is length times width. So again, length times width. So our length is 2x, our width is x. And so technically our area for the rectangle part is just 2x squared. 2x squared. All right, but it says, again, the total area. So that means we have to have the area of both the rectangle and the square. So here, if we look at the area of a square, that's just a side squared. So whatever side it is squared, doesn't really matter because it's a square, so therefore all the sides match up or are the same. So here technically we have y squared here because that's our side right here. So plus y squared. So that's our area formula that we're looking for. Area. Woo, yeah, we love area. Area. Woo, 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 woo. Area. All right. So with that, we have that step 2 done. We've created the equation that deals with our area that we're trying to optimize. But then again, step 3 says, okay, you cannot have two variables in that optimized formula equation, you have to have one variable. So we have to figure out a way of manipulating that so that we only have x's there or only y's. And so there should be something else in the problem that should be able to help us out to figure out what other formula we can use to be able to get this done. Which there is a number that's there. It said there's 50 centimeters of wire that's going to create this rectangle and create the square if there's some left over to create that square. So if it's 50 centimeters to create all of this, that pretty much means, again, that 50 is our perimeter. Because 50 centimeters must make up the whole outsides of these. The whole perimeter must make up those outsides there. And if they don't, that means that's not a perimeter. But it says here that it's supposed to make up the whole thing, so therefore it's perimeter. So if we're looking at our perimeter, again, total perimeter is 50 centimeters for both of those two shapes. So if we're looking at this part, if we look at the perimeter of each one of these, we know this is 2x for this side, we know this is x for this side, because it's rectangle, so the opposite sides are equal to each other. So that means if we add them up to find our perimeters, that means for our rectangle, we would have x plus 2x is 3x, plus 4x, plus 5, plus 6x there. Or you can say 2x plus 2x is 4x, then 5x, 6x. Either way, still 6x for the perimeter of the rectangle. All right, for the square, we have y's on all four sides. So y, 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 y. So with that, it's 4 y's. So we set plus 4y. So the perimeter of the rectangle plus the perimeter of the square should equal the perimeter of the whole thing, which is 50 centimeters. So here. And again with this third step will always be somewhere in the problem that you must figure it out. So you have to understand what the numbers mean and not just, oh, there's a number in the problem, that's whatever. You have to know what the number means. So if it gives you 50 centimeters, you have to realize, okay, that's for the whole thing. That means perimeter. But if you can't figure that out, then you'll be stuck on this step. So you have to deduce it, figure out what's going on. But again, the process follows, it's really the same. So it's kind of sequential every time we do this. There's always some type of volume or some type of area formula, and then there's some type of perimeter or something that will help us to find what we're looking for. So it's not bad. All right, so here, again, because we need to have just x or just y, we need to be able to solve this one here, this equation, for either x or y, and be able to get switch it out so that we have all x's over here or all y's over here. So let's go ahead and solve this for y again, just because everybody likes to solve for y. That's what we normally do. All right, so we did 50 minus 6x equals 4y. We divide everything by 4. We get 50 divided by 4 minus 6 over 4x equals y. All right, so when we simplify things down here, we would get that this is 12.5 minus 1.5x equals y. Okay, so decimals are okay. It's okay to have those. So now that we know what y is, we're going to substitute in for y there. So here, so that this way we can actually have all x's and not x's and y's. And don't forget to put the quantity portion up here because it's quantity squared. So we have to make sure we put that quantity part there too. Okay, so here we're going to FOIL it. We should know already. This means we have to FOIL it out and simplify it down so we have an equation that's easy to put into the calculator. But again, if you want to just go ahead and put it in the calculator that way too, that's great. Because once we do this next step and solve it out and work it out, when you go to calculus, if you mess up this next step of simplifying it down, that means your work is wrong from this point forward. So that means there's like let's say like 4 points for the information that's below this, you will lose 4 points. If there's like, for example, let's say there's 6 points for all this whole all this work here for the actual calculus problem on the AP test. If you get to this point and you solve it out wrong, whatever is below this is wrong, and you lose all those points for that that question on the AP test. All right, so here you can put that directly into the calculator, and I think I actually might do that. Let's do it. All right, so I just jumped here again with it, but I just want to make sure you guys can kind of see what's going on. We put the equation into Desmos there, as you can see right here, that original equation. Now, with that, I wanted to make sure you actually, again, like we talked about last time, was looking at the actual leading coefficient and kind of telling if it was a max or a min. So here, the leading coefficient, I went on and expanded all this out and foiled this portion here, and I went on and combined like terms and everything. So that equation ended up being, the simplified equation ended up being this part right here. Now with that portion of it, let me use blue. The leading coefficient is positive 4.25, sorry. Which means that it's going to open up, which means it's positive, so it means it's open up with the function. So that means we're going to have a minimum, which is what we're trying to find is the smallest possible. So we found that minimum. We're going to find that minimum here. All right, so with that, and I'm losing dots. So with that, we come over here to Desmos, and we find that our minimum point is right here. And I think I did it right. Yes. And let's actually pin it there. All right. So we get an x value of x equals 4.412. Right? So again, it says, what should the dimensions of the shape be if you want the total area to be as small as possible? So again, we're finding dimensions. And again, I just read the actual question part. So here, we're going to go back to this part right here. You come here, or again, if you want to come up here and solve for y, you can do that too. We're going to use this portion right here to help us to find that. And we have one extra step that we're going to end up doing here because it's in the problem, so we have to make sure we do that right. So we have the y. We're going to substitute that 4.412. And if you did it in a graphing calculator too, you should still have that. And when I have the time, I'll actually go back and do a video for that portion of it so you can see it too. All right, so when you put that in, you will get the value of, let's see, where's my answer for this one? 5.882 centimeters. So that's our y dimension. That's your x dimension is there, your y dimension is there. But again, really quick, it said your dimensions. So I'm going to jump back up to the top of this and actually look at our picture again. Our dimensions were x, 2x, and y. So here we found x and we found our x, we found our y, but we also need to find 2x really quick, which shouldn't be hard. That's just 2 times 4.412. So we just multiply that out. Everybody should be able to look at that and tell what it is. So 2x has the dimensions of 8.824. So in other words, our length is 8.824. Our width is 4.412 centimeters for the rectangle. And then the y, this square, is actually 5.882 for each side. And that's it, guys. We found our dimensions for the smallest area.